Hi, welcome back to Bexhill West. I'm James. Thank you for joining me. Now what you see here are my very first attempts at using the Monport GA30 watt Monport fibre laser. It's my very first attempt at using a fibre lasing machine, and what you see on the screen here was one of my very first attempts at using it on a particular project. Now these are little model railway signals. They're quite tiny, and this gives you an idea of some of the detail that can be achieved. Now I'm going to be doing a sort of a test of this machine over the next few weeks, and I've got quite a complex project in mind for it. First of all, I need to learn how to use it. Today's video is just set up, have a little look and get a flavour of what this machine can do. Now chemical etching of metals, brass, nickel, silver, also stainless steel, they've been staples of the fine scale model making world for decades, and in fact I've got a etching set up in my studio. That's one day I'll make a video showing us making something with it. But that's all fine, but one of the drawbacks to it is the chemicals are a little bit messy. They tend to go off quite quickly, so you have to keep monitoring them and keep them all sort of at the right levels to get reliable and repeatable etching. So I'm hoping that the machine inside this box is going to enable me to do many of the same etching and cutting processes, but from a digital file. All of my artwork is produced on the computer anyway, so basically it will cut out the chemical process and I should be able to go from computer screen to finished part much quicker. So let's open the box up and see what we got. So one of the great selling features of this machine is it's very easy to set up. This arm, if I can just release it from its packaging, swings vertically. And we've got some screws here that we simply pop in to fasten this column in place. There's two of those. I'll do the second one in just a moment. So it's pretty clear to me that you're seeing the back of the machine now. You can't really get a good idea of how this all looks, so what I'll do is I'll decant this from the box and set just the machine up and we can have a closer look at it. But I'll do that off camera because that's going to involve a bit of heaving and shifting. So I'm really impressed with how easy and quick this machine has been to set up. Other than those two screws which I had to put in when I elevated the column, there's just a power cable and a USB lead to plug in, and that's it, it's good to go. So whilst I have quite a bit of experience of using laser machines generally, I've never used a fibre laser, and one of the things that I'm aware of is it's critical to get the focal length sort of precisely spot on. And one of the great features which has attracted me to this machine is the fact there is a focus button and it will automatically focus onto the workpiece. That's going to be a real benefit, particularly for a beginner like me learning how to use the machine. So I've got the machine inside and up on the bench, and we can have a quick look at the back because that gives us an indication of what's what. We've got a power supply going in. There's a port for the USB cable. Now my advice would be to plug that in before you finally position this machine, because it's set quite a way inside the housing of the machine, so it's a little bit like this way round is really easy to do, but if you put it on the bench and it was at the back, that would possibly be a bit of a struggle to line up. Anyway, it fits nice and positively. There's also a connector here for a rotary device. Now I haven't got the rotary device, so I can't comment any further on that, but that's where that would plug in. Now I've used this machine a little bit already, sort of testing it out, and I can already see that where we've got this cooling fan on the back here, I've got some dust here, so I think it's worth, when you're working in engraving, giving this a vacuum out regularly so we don't fill the inside of the machine up with particles. This flexible conduit here takes the wiring and of course the fibre cable from the laser unit in the base here up to the head. Now this thing's quite heavy, you won't want to keep lugging it around too much, about 30 kilos, so I'll move it back into position off camera and we can have a look at the lens and we'll set it to do a couple of little jobs. So looking at the front of the machine, it's a very simple fascia panel. We've got two switches. We've got the main laser on-off switch. We've got a switch labelled foot switch. Now I believe some of these machines you can operate using a foot switch to start and stop jobs. This machine doesn't have a foot switch, but there's the equivalent button on the front. That's why it's labelled foot switch. Three buttons, one to move the head downwards, another one to move it up, and autofocus, and we'll look at what they do exactly in just a minute. So we can power the machine on with the switch at the back, and immediately a red dot, sort of target light, has appeared on the table of the machine. If I turn the laser on itself, you'll hear the cooling fan. That's now calmed down, and we're ready to go. That's all there is to setting this thing up. There's like two wires to plug in, and then it's pretty much good to go. So this shot gives us an idea of the form factor of the machine. We've got our engraving table, and we've got our sort of engraving arm that comes out, and this contains the galvo head. Now the galvo head is a series of two mirrors which directs the laser beam sort of in the X and the Y direction and enable it to trace over the work table. There's a lens cap on here, and that's the lens unit. We'll look at that a bit more closely in just a minute. Now this machine has autofocus. Basically, if I press the focus button, the head of the machine will move, and there are two red dots on the table of the machine here, and they're created by two marker sort of laser diodes in just under the head here, and it will detect when those points meet one another, and that's it, auto-focused. So for example, if we had a slightly thicker object here, it will focus on the surface of the material rather than the bed. Now there is a hand wheel on the top up here that you can do this manually if you prefer. So this is what we're going to have a go at engraving first of all. Just a simple steam locomotive onto a anodised aluminium business card. Now I'm still learning how to use the machine, so these are the settings that I've chosen, and it's worth mentioning here that I'm using Lightburn. Now Lightburn is a paid for piece of software, and in fact to use a galvo laser such as the one I'm using here, you actually have to upgrade the software. But you can use a free piece of software called EasyCAD, and the machine actually comes with EasyCAD. However, I'm used to using Lightburn and not wanting to learn a new piece of software whilst learning a new machine at the same time. I'm just using Lightburn for now. Now if I click on one of my two layers, I've got the black layer and the blue layer. The blue layer I'm going to fill, so let's change that to fill. If I just open up the black layer, we've got a number of controls here that we wouldn't normally see on say a diode laser or a CO2 laser. We can, for example, control the frequency. There's other things such as wobble, for example, which are peculiar to a fibre laser. Let's not get into those just now. Let's run this and see how it works. Now when I click frame, it'll help if I actually select those are the bits I want to engrave. I click frame, and on the bed of the machine a kind of a projection of the outline of the artwork appears on the table of the machine. So I can slide my business card under, line that all up, and we'll hit start and we'll see how that works. It doesn't take long. So hopefully you could see as it's burning away the coating on the material, hopefully you could see this smoke coming off. Really, this does need to be extracted. And there we go, job done. So if I bring this up to the camera, hopefully it will focus. You can see just how clean, nice an image that is. Really, really good. Now, the kerf, or the kind of the thickness of the laser beam, is very, very narrow on one of these machines. It's a fraction of what you would expect off of a diode or a CO2 laser. And consequently, we can set this to kind of scan backwards and forwards at sort of micro settings and produce really, really intricate pieces of artwork. Let's try something else in a similar vein and see how we get on, and then afterwards we'll have a go at something a bit more complex. So a good question might be, what is a fibre laser? And in this case a Monport fibre laser. What's it intended for? What's it designed to do? Well, primarily it's designed to engrave on a wide variety of materials. It will even engrave on plastics with no trouble at all. But for here I've got a piece of stainless steel, and I'm going to run a simple engraving program just to give you an idea of one of the things that you could do with a machine of this type. Now this is very difficult to film because the light's reflecting off the shiny stainless surface, but hopefully you could see a number of things I've here. Firstly, we've got quite a nice engraved setting. It hasn't actually engraved into the material per se, it's still quite flush with the surface, but you can see we've got a sort of a coloured print effect, and by adjusting those values we can get different coloured effects, different sort of colours of the rainbow. So I've done this test, I've kept a log of those settings. What I'm going to do is change those settings and we'll run exactly the same cut down here, and we can hopefully see some differences in the quality of the outcome. So then here's, again we're having a problem finding there we go, something like that to try and keep the glare off of it. Now I realise I've made a terrible boo-boo here. The line interval of this second engraving I did was actually 0.001 millimeters. I forgot to change it on here, so I've now permanently engraved a mistake onto this material. Now hopefully you can see we've got slightly different colours going on there, and again this isn't engraved as such. I can't really feel that, but it's permanently marked on. It's kind of, my understanding is it just sort of changes the molecules or whatever it is just under the surface of the material, so that's kind of like a permanent, won't rub off etching. And it's really neat. I ought to try this with a non-reflective material so that you can appreciate just how good a quality that is. But so the thing here to bear in mind, that was with a line interval of, as I say, 0.01. Just to give you an idea of the sort of finesse that can be achieved with this machine. It's brilliant. Of course, engraving things in 2D is all well and good, and in fact that's really what these machines are designed for. If you look on YouTube, you'll find no end of tutorials and things showing how to get the best out of the machines, and this video is not one of those. I've literally just got the thing and I'm learning to play with it myself. Now Monport have very graciously agreed to leave this thing with me for a few weeks to give me the time to get to know it, and I promise I'm going to do another video in which I'll make something hopefully quite impressive with it, really put it to its test it to its limits. But me being me, and even though I'm just sort of in the first stages of finding out how to use it, I thought I'd have a go at something a little bit more ambitious. Now, as good as 2D is, I think viewers of this channel would like to see something three-dimensional, and it didn't take me long to think of a suitable project, and so I'll get up on my screen now something that I fancy having a go at making. Now, it's no surprise that when I engraved that business card earlier on with a F-class railway locomotive, there's no surprise that that's exactly what I'm going to have a go at. So I've got some images on my screen here, including a scan of an original document which I think I've shown on the channel before. And what I've done is I've traced that in my CAD software. Ignore all of these measurements, these are just things I've been working on, figuring stuff out. Anyway, I've managed to decipher from all of this mess a set of components, and let's zoom in just on those. Here we go, to make the chassis for this steam locomotive. I'm going to use nickel silver, it's 0.45 of a millimetre thick, and I'm going to try cutting it out. Now I can immediately anticipate I'm going to run into a problem. In fact, I've ordered a piece of special hardware to help me get around the problem. I've not got that yet, so we're just going to carry on anyway and have a busk at cutting some of these bits out. Now there's a bit of messing around here as I was figuring out the best thing, so what I'll do is I'll just put on the screen some shots of the machine cutting. The secret with this is to try and keep the temperature down in the material, so rather than going at it like a bull in a china shop with a really high power and a fast speed, or rather a slow speed, and try and chomp through in one pass, I've deliberately done this in lots and lots of passes. So I think there's probably something like 20 passes on each sort of cut line. So in doing so, I've been able to keep the speed up and try and minimize the heat into the material. Now you'll see that the material does heat up and it does sort of twist and pucker up a little bit, and that's because really the material is not being held properly. Now you'll see me cheating here. This is an absolute bodge, don't do this, I don't recommend it at all. I'm just temporarily sort of trying to weigh the material down, but it did work. Now I mentioned a piece of hardware that I've ordered, and I'll put a picture of it on the screen now. This is a sheet metal vise that we can clamp sheet materials in, such as this, and it will hold them nice and firm and rigid. Now I don't have that machine, it's not arrived yet, so I've not used it for this video. So literally the bits I've cut out in this video have been a bit of a bodge. But if we move on to the assembly, I'm going to whiz through this really quickly. I'm not going to show this in any detail. In fact, we'll probably make a separate video out of this. But you see the parts come out beautifully. Really, really nice indeed. And being nickel silver, they're quite straightforward to solder together. And it's not long before I've got a complete assembly. Now the wheels and the bearings are, I had those in stock, I've not made those with the machine, but this chassis frame is entirely made using the Fibre laser. Now we've got some interesting design elements here for all of the nerds watching this. We've got suspension springs, so it's these four wheels on this locomotive are all sprung. I haven't made the bogie yet, we'll do that, and then there'll obviously be another four wheels on it. Now having fitted the wheels, the thing runs on track perfectly. It's really, I'd say, impressive. The fact it's folded up first go, there's no binding, there's not much in the way of tolerance in the bearings and stuff. It's kind of got to be right, and yeah, there we go, it absolutely is. Now this really is why I wanted to test a fibre laser machine, and why I'm really grateful to Monport for sending me one that I could just have a play with, because I've not seen parts like this cut out with a fibre laser. In fact, I've read online that it's the wrong machine to use and don't do it. Well, it's not a quick process, but it's a really handy process, being able to build complicated stuff like this on the desktop. So this then is my first little play at doing something with the machine. The machine is undoubtedly excellent. Its capabilities are far beyond my abilities at the moment, but I've been working quite hard over the last week trying to suss out how to use it and get the best from it. So this is an advert for what the machine can do. I'm still learning. There's plenty of tutorial videos on YouTube that I'm sure will show you exactly how to use such a machine. But hopefully over the next 2 or 3 weeks I've got another little project in mind that I've been developing, and we're going to have a go at creating it with this machine. I think this machine could be a game changer in the sort of the scale model world. Now, I mentioned that nickel silver sheet I've used is 0.45 of a millimetre thick. I've used I've cut through 1 millimetre thick material also, and I've got some 2 millimetre brass to try as well, and I'm quite certain it will cut through it. It will just take lots and lots of passes. Clearly there's loads of other things that could be done with this that I've yet to play with, but as machines go, this is pretty good. A most excellent toy indeed. So that's it for today's video. We'll put a pin in it here. That's my first sort of play with this wonderful Monport fibre laser. We'll come back to this again in a few weeks' time when I've learned how to use it properly. I'll have the sheet metal vise, which means we'll be able to cut things a little bit more precisely, and I'm going to have a go at doing something hopefully quite impressive. So till then, I'll see you soon. Cheerio.